Hi, this is Trent Ford, and I'm the Illinois State Climatologist based at the State Water Survey here at the University of Illinois at Urbana-Champaign. And I really appreciate you all inviting me to present as part of this series. Today I'm going to be talking about human and ecological impacts of climate change here in Illinois. So first we need to get an understanding of what the climate system is. A lot of folks associate the climate system with the atmosphere, and that's definitely part of it. But so are the biosphere, all of our vegetation, our oceans, our ice, and all of our land and subsurface. What this means is that any change in any of these systems affects change in all of the other systems. So what we've been witnessing over the last 100 to 150 years is changes in our atmosphere that have created all sorts of changes here on the ground, as well as in our oceans and to our vegetation. So what's been happening? Well, overall, this is a schematic of Earth's energy budget. The majority of energy here on Earth comes from the sun. It's shortwave energy. Much of that is absorbed and re-emitted by the Earth's surface as long-wave energy. Now, certain gases in the atmosphere allow the shortwave energy to come into the Earth system, but block, absorb, trap the outgoing long-wave energy. So therefore, the concentration of these gases, namely carbon dioxide, methane, and water vapor, their concentration dictates Earth's energy balance. Now, their concentration also varies in time due to both natural and anthropogenic causes. But overall, as we see the concentrations of particularly carbon dioxide increase, we see global average temperature increase. And that's just not a relationship that's been borne out over the last 100 years. It's basically over millennia, over the entire history of Earth. What we've seen over the last 100 years or so is consistent increases in atmospheric carbon dioxide concentrations. This graph here is showing observations of CO2 concentrations at Mauna Loa Observatory in Hawaii. You can see that when we started taking observations back in the late 1950s, the amount of carbon dioxide in the air was measured at about 315 parts per million. That's a volumetric measurement, how we represent carbon dioxide. Just recently, the July 2021 observation was 417 parts per million. So we see that consistent climb. And I want you to remember this 417 parts per million because it'll be important for historical purposes. What I'm showing you here is variability, long-term variability in the concentration of carbon dioxide in carbon dioxide concentrations. In the red line here, going all the way back 800,000 years before the present. Now, this was taken from the Dome Sea ice core in Antarctica. The nice thing about ice cores is that you can directly measure the carbon dioxide concentrations of past atmospheres because of the air bubbles that are trapped within the ice. So these are direct observations, not reconstructions based on proxies or anything like that. What you can see is that over the last 800,000 years, predating humans, we see lots of variability in carbon dioxide concentrations. But what we don't see is that any time in the last 800,000 years, global atmospheric carbon dioxide concentrations reaching over 300 parts per million. And if you remember from my previous slide, today we're at 417 parts per million. So essentially what we've witnessed over the last 100 years is not only an unprecedented increase in the amount of carbon dioxide concentrations, but also an unprecedented level of carbon dioxide. And as we know from Earth's history, is that carbon dioxide concentrations generally dictate global average temperature. So what's causing these changes in carbon dioxide over the last 100 years? Well, the increased radiative forcing, basically the increase in the amount of energy stored here on Earth due to carbon dioxide concentrations, due to greenhouse gases, can be attributed virtually all to human activity. And most of that is through energy creation processes through the burning of fossil fuels. So what we've seen, this increase in carbon dioxide concentration over the last 100 years, is by and large, or virtually entirely, due to human processes. That's that word anthropogenic. It has an anthropogenic influence. So the results to this increase in carbon dioxide concentrations, a consistent increase in global average temperatures. This is what is known as global warming. What I'm showing you here is global average temperature since the late 1800s from 5 different data sets. We can see that consistent rise in global average temperature since about the late 1950s especially. And this is directly due to anthropogenic sourced increases in carbon dioxide concentrations in our atmosphere. So this is what global warming is. Now, what you can see is there's not a large change overall in the global average temperature. It's less than 1.5 degrees Fahrenheit over the last 150 years. However, because we're talking about an increase in the global average temperature, this change, this 1.5 degree Fahrenheit change, is representing a huge change in the amount of energy stored on Earth, which affects global and regional climates. And so what I'm going to talk about for the rest of this talk is climate change. Climate change is driven by global warming, changes in the global average temperature. And because our global climate system is so complex, as I showed you with that first slide, we see different regions with different changes in climates as a response to anthropogenic global warming. So what I'm going to do here is discuss changes that we've seen in Illinois and impacts from those changes. So I'm going to start with temperature. Overall, in Illinois, over the last 100 to 150 years, we have gotten warmer. Over the last 120 years specifically, the statewide annual average temperature has increased by about 1/10 of a degree Fahrenheit per decade. So we're about anywhere between 1 and 1.5 degrees Fahrenheit warmer now than we were at the turn of the 20th century. What I'm showing you here on the right-hand side, these maps are showing the different warming rates by county per season. So you can see the darker areas of red, the shading in red in winter and spring in particular, show higher rates of warming. So winter and spring are warming at a faster rate as far as average temperature is concerned than, for example, summer and fall. Now, when we break this down between daily maximum, daily minimum temperature, what we see is that the largest change by far in all of the seasons is in the daily minimum temperatures. That's particularly the case in the summertime when we don't actually statewide see a significant change or have seen a significant change in daily maximum temperatures during the summertime, just our daily minimum. So nights overall are getting warmer. But a big pattern here that I want you to pick out is that winter and spring historically have warmed at a much faster rate than summer and fall. So what does this mean? What does overall warming mean? Well, one effect that it has is a longer growing season. What I'm showing you here, these two maps are showing the contours of the average growing season. That's the time elapsed between the last spring freeze and the first fall freeze in days. And what you can see, the left map is showing the 1971 to 2000 average. And on the right-hand side, our most recent 1991 to 2020 average. What we can see here is that throughout Illinois, we see an increase in that growing season length. That's because the last spring freeze is occurring earlier and earlier in the spring, and the first fall freeze is occurring later and later in the fall. So, for example, for southern Illinois, we see that the growing season just over the last 50 to 60 years has increased by 10 to 25 days. And so a significant increase in that growing season length. That's a trend of about 3 to 5 days per decade in southern Illinois. Now, in some ways, this can be beneficial. As I'll talk about agricultural impacts in a little bit here, a longer growing season means that we can get some of those longer, the longer required growing degree day crops mature in parts of northern and central Illinois that we weren't able to before. However, the primary cause of a longer growing season, those warmer temperatures, also have some pretty negative impacts as well, as I'll talk about in a little bit. What we've also seen is overall higher humidity. And so what I'm showing you here is the summertime average dew point temperature at Chicago's O'Hare Airport going back to 1947. The dew point temperature is the temperature at which the air is saturated, and therefore the higher the dew point temperature, the overall higher the humidity. What we see, a lot of variability, but overall a long-term positive trend in summertime humidity. That's what we're seeing actually this summer of 2021, was that temperatures were, and this is something we've seen here this summer, where the dew point temperature has stayed very high throughout the day. And so those nighttime temperatures don't drop below, so we don't get a whole lot of recovery at night after a very hot day. So overall, when it comes to human health, higher humidity, especially in the summertime, can be detrimental to human health. So what do models project as what we expect into the future? Well, overall, model temperature projections throughout the 21st century shows much of the same throughout Illinois. Continued warming in all seasons, but the largest warming in wintertime, as we've seen in historical records. So winters are projected to continue to warm at a very fast rate. And what that means is an overall projected higher frequency of the very warm nights. That's the nights when we get above 70 degrees Fahrenheit or don't get below 70 degrees Fahrenheit. And higher frequency of very hot days. That's the days where our maximum temperature gets at or above 95 degrees. What I'm showing you here on the bottom are plots of those state-of-the-art projections from several different global climate models. On the left is simulations or projections of the annual number of very warm nights across northern Illinois. And on the right is the annual number of very hot days across northern Illinois. Now, the difference in color here between the red and the green shows difference in the scenario, basically the emission scenario for under which those models are run. So the red areas, the red shaded areas are showing the higher emission scenario. That is when the models are run under the assumption that global carbon dioxide emissions aren't going to change and may actually increase between now and the end of the century. The green area of shading indicates the lower emission scenario where we curb carbon dioxide emissions very, very soon within the decade and go to net zero by the middle part of the century. The reason we run models under different scenarios is to test not only the sensitivity of the climate to human interactions here, how much emissions we emit, but it also gives a good perspective to say if we reduce carbon dioxide and overall greenhouse gas emissions or reduce carbon dioxide concentrations in the atmosphere, here are the change in the impacts and the overall rate of climate change across the world and in different regions. So what we see is a very strong bifurcation between the red and the green regions. They're separated quite strongly, which indicates that fewer emissions equals less warming. The amount of change in the number of very warm nights and very hot days in northern Illinois between now and the end of the century is very sensitive to overall global carbon dioxide emissions and global carbon dioxide concentrations. To put a specific number to this, the difference between the higher and lower emission scenario results in overall 30 fewer very hot days and 30 fewer very warm nights between those two emissions by 2080 in northern Illinois. So if we can curb those carbon dioxide emissions within the century and go to net zero by mid-century, what the models are indicating to us is that, suggesting to us is that that could mean the difference between an entire additional month of 95-degree days and 70-degree nights and not having that. So the impacts of that can be tremendous. Okay, now talking a little bit, switching gears to talk about precipitation. So we're getting warmer. Overall, we're also getting wetter across Illinois. What I'm showing you here on the right-hand side is the plot of the annual total precipitation going back to 1895 in the Northwest Illinois Climate Division. Northeast Illinois is about the same. Overall, northern Illinois has increased total annual precipitation by about ½ an inch per decade. So overall, the northern part of the state is about 5 inches wetter now than it was the turn of the 20th century. So we can estimate that's about like chalking on another June onto the year. So overall, we're wetter. Now, when we break this down seasonally, in both northern and southern Illinois, what we see is that the summer trend in precipitation, the increase in summer precipitation, is 2 to 4 times larger than that in other seasons. So all seasons are getting wetter, winter, spring, summer, and fall, but the change in summer precipitation is much larger than all of the others. Along with more rainfall, more precipitation overall, we're also seeing more intense precipitation. Now, there's lots of different ways we can represent rainfall intensity. It can be a difficult subject to breach, can be a difficult subject to communicate. One way I like to do it is talking about the estimated recurrence interval. So you may have heard this before, especially with flooding. You think about the 100-year flood, the 500-year flood. The kind of terminology relates to the estimated frequency or how often we would expect flooding of that magnitude to occur. So for example, the 100-year flood has an annual rate or annual probability of happening of about 1%. So if you were to say getting a level that's a 100-year flood, you have a 1% chance of hitting that level any given year. Okay, we can do the same thing for rainfall, and we have in Illinois. Back in 1989, folks at the State Water Survey published the Bulletin 70, which was the first real statewide estimate of precipitation recurrence intervals. And because of our changing climate, it was recognized that it should be re-estimated, and was back in 2019. So we have really 2 snapshots in time separated by 30 years that give us estimates of precipitation recurrence, or the estimated frequency of different types of events. Now, I have a bunch of different events listed here that have occurred just in the last year across Illinois, and their estimated recurrence intervals based on the 1989 estimates and how much that's changed based on the 2019 estimates. One event that I want to pick out in particular here was last May, or May of 2020, in Chicago, when at Midway they recorded 7.88, almost 8 inches of rain in 4 days. Now, this was the event that flooded Interstate 80 and caused flooding in the basement of the Willis Tower. Based on the 1989 estimates, that was a 50-year event, meaning it has a 2% chance of happening any given year. So if you're building infrastructure in the city of Chicago, you say, we have a 2% chance of getting that much rain in that period of time. So the impact that occurred because of that, 2% chance of any given year. Based on the 2019 estimate, it has a 4% chance of happening any given year, which means we've doubled the probability of that event occurring. And this is really how climate change is linked to extreme events. Climate change doesn't cause hurricanes, extreme precipitation event, drought events, wildfire, those sorts of things. It makes those events more likely and of higher magnitude. And that's what we're seeing here in Illinois statewide. I use the example from Chicago, but statewide, we're seeing extreme rainfall events increase in their intensity and their frequency. So it was very possible without the effect of humans and our carbon dioxide emissions over the last 150 years to get 8 inches of rain in the city of Chicago. What our climate change has done over the last 150 years is make that much more frequent, a much higher probability of that occurring. And so what that means is impacts to infrastructure, to humans, livelihoods, all of that also become much more of a risk. So what do model projections say? Well, they indicate, similar to the temperature projections, kind of a business as usual. Projections indicate wetter overall conditions in Illinois and also maybe a bit of changing seasonality. So what I'm showing you here, these maps are showing the overall projected change in seasonal total precipitation, winter, spring, summer, and fall, expressed as a percent. And what you can see is the darker blue and green parts in winter and spring in particular indicate that those seasons are projected to continue to get wetter. So as we project winter and spring to continue to get warmer, they also are projected to get wetter. The summer and fall, they are projected to decrease precipitation, get a little bit drier. However, there's quite a bit of uncertainty in those projections. So we may hear these things about springs getting wetter, summers getting drier, have this switch from flood to drought. There's a lot of uncertainty in those kind of projections. Much more confidence in the winter and spring getting wetter pieces, and there's certainly impacts from that. But as far as summer precipitation projections are concerned, there's a lot more work that can be done to increase the confidence of those types of projections. Overall, this is kind of giving you the same kind of snapshot. These figures on the bottom are showing the same kind of figures with, as we show with temperature, the projections under the higher emissions and lower emissions scenario. The left figure is showing projections of annual total rainfall in inches in northern Illinois. And the right-hand side is the annual number of days with rainfall greater than or equal to 2 inches. And so what we can see here, again, model projections show continued higher annual precipitation, but you don't see a lot of separation between the green and the red. What that means is that these projections are not segregated by emission scenario. So irrespective of changes in carbon dioxide emissions, we don't really see much change in the upward increases or projected increases in total annual precipitation. More intense precipitation is also projected, as you can see the upward trend here in projections of those extreme precipitation or very heavy precipitation days, those where we get 2 inches or more. And they are a bit more sensitive to the emissions, where we get fewer of those very intense precipitation events under a lower emission scenario than a higher emission scenario. Overall, it's about half a day per year or 1 day per every 2 years reduction between the lower and the higher emission scenario. So overall, the impacts aren't quite as sensitive. The impacts of precipitation aren't quite as sensitive to the emissions as temperature are, but we still see some of that sensitivity there, especially with the rainfall extremes that really have most of the impact when it comes to climate change. Okay, so speaking of impacts, we're moving now into sectoral impacts, impacts to natural, human ecosystems, agriculture, all of that, to discuss how climate change has impacted us so far and how we expect those impacts to change into the future. First one is health. This is the one that I would say sometimes I'll be asked on an interview, what is it that keeps you up at night, or what is it that you're most concerned about? And by and large, it's the public health implications of climate change. And not only, I mean, of course, the livelihood standpoint is really important, but also the economic cost of public health implications are immense. What we're showing here on the right hand side, this map is the green dots. The size of the green dot indicates the heat hospitalization rate per capita heat hospitalization rate estimated or calculated over the period 1987 to 2014 across Illinois. When we see increasing temperatures, particularly in the spring and summertime, what that does is it increases the risk of heat-related illness and heat health issues related to that heat exposure. Now, when we think about heat health issues, especially in northern Illinois, often events like the 1995 heat wave in Chicago come to mind. And certainly we have many communities in the northeast part of the state that are very vulnerable to being exposure to extreme heat. And that is an issue moving forward as projections indicate the exposure to extreme heat increasing all across the state. But also, research is showing that risk in especially southern and western Illinois' rural counties and communities actually exceeds those in some of the urban regions of the state. And we think about, and when it comes to health implications from extreme heat, one of the communities that is most at risk are farm workers, those who are working out in the fields all across the state. And so when it comes to public health, one of the biggest implications is the increase in heat exposure from that. Now, just to quote a study here, there was a study done a few years ago from the Minneapolis-St. Paul area that estimated that the annual cost of public health issues related to just extreme heat exposure, not extreme cold or heavy precipitation, anything like that, but just the public health cost of heat exposure in just the Minneapolis-St. Paul area was well over $1 billion annually. So we can expect that for the entire state of Illinois, that number would be magnified beyond that. So it's not just a livelihood issue, a health issue, but also an economic issue when it comes to climate change impacts on public health. Another impact of public health is through vector-borne disease. What I'm showing you on the right-hand side is the results of tick surveys all across the state from 2019 and 2020. Increased temperatures, especially in the winter and spring, have helped expand the range of ticks and mosquitoes across Illinois and the diseases that they bring. So, for example, the Heartland disease, which is spread by the Lone Star tick, was first confirmed in Kankakee County for the first time last year. And so when we talk about changes in temperature, a lot of times we focus, as I did on the last slide there, on changes in summertime temperature that change the exposure to extreme heat. However, changes in winter and spring temperature also have significant implications, and one of those is the change in vector-borne disease. We also see a higher prevalence of Lyme disease in West Nile and Northeast Illinois, especially the latter of those West Nile related to short dry spells. And another emerging vector, the Gulf Coast tick, has been shown to be expanding northward into Illinois. It was confirmed in the St. Louis Metro East area the first time last year, and that brings with it a whole slew of diseases as well. So this is something that we're going to be dealing with as we see the overwintering of ticks and mosquitoes increasing, especially across the southern parts of the state. It means that they can have a higher incidence or prevalence across the northern part of the state into the summertime. So those increasing winter and spring temperatures, decreasing the amount of very cold temperatures we have in the winter especially, that can increase vector-borne disease, create a significant public health issue. Another impact to, and this is really an environmental quality impact as well as an agricultural impact and an ecological impact, is soil erosion. So we talked about the changing precipitation patterns and especially increases in extreme precipitation. That enhances soil erosion or soil loss through runoff. So when we get a large amount of precipitation in a short period of time, the vast majority of that rainfall will not infiltrate the soil, but will instead run off into our streams and creeks and rivers and carry with it nutrients from these soils, but also the soils themselves. Now, this is a serious environmental issue, as we know from the hypoxia zone, which is caused by nutrient runoff in the Midwest, and other sorts of issues like harmful algal bloom outbreaks and things like that from extreme rainfall and nutrient runoff from agricultural fields. However, it's also an economic issue. I'm showing on the right-hand side results from a paper study published just this year that did, for one of the first times, estimate the economic loss in the Midwest to just soil erosion from climate change. The new estimate suggests that 30 to 50% of our organically rich A horizon, that's that top layer, that nice top black layer of soil, has been lost. 30 to 50% has been lost in the Midwest since the 1800s. That does a number of things. First of all, the loss of organic matter decreases the overall fertility of the soil. But it also means that we have to, in order to successfully grow crops, we have to add more organic matter, which is fertilizer and other things that are put on the soil, which, when we get heavy precipitation, runs off into our streams and creates lots of environmental and water quality issues. However, in a bit of a twist here, increased rainfall intensity also reduces the resilience of our ecological and agricultural systems to drought. So when we get 2, 3, 4, 6 inches of rain in a short period of time, only a small fraction of that rain actually infiltrates the soil. The vast majority of it runs off, which means that water isn't there at the time that the weather dries out and we get a prolonged dry spell. One statistic to throw at you is a specific from last year. So last summer of 2020, Peoria got about half of its overall total summer rainfall in about 6 hours. It was very dry in June in Peoria. Then they got 6 to 7 inches of rain in a 6-hour period of time in the beginning of July. And then it was dry beyond that. So what that means is that those soils that are around the Peoria area are drying out, get a burst of rainfall, but again, because you're getting 6 inches of rain in a short period of time, the majority of that isn't infiltrating, so you're netting less in your soil, making you overall less resilient, more vulnerable to drought conditions following that. And that's what we're seeing. So overall, what this study estimated is that per farm, the annual loss per farm in Illinois, just due to soil erosion from climate change, is anywhere between $5,000 and $40,000. That's not $5,000 to $40,000 per county. That's per farm that folks are losing due to soil erosion. And that estimate does not account for the decreases in soil health. So not only are we losing that organic matter, we're also losing those vital soil microbes that increase our soil health and fertility across the state. So overall soil erosion, nutrient runoff from increased precipitation, let alone flooding of crops and natural ecosystems, but the soil erosion and nutrient runoff issues alone are tremendous challenges moving forward. And as I can relate it back to what we just talked about with the projections are indicating that increased precipitation intensity is going to continue. And it's going to be a particular issue in the winter and spring as we continue to increase our winter and spring precipitation when our agricultural fields are bare or fallow. And so that becomes even more of an issue when we don't have root matter there to solidify that soil. We also see serious natural ecosystem impacts. So I'm talking about forest ecosystems here in this slide. And there are major climate change impacts. So for example, we get more intense precipitation, which means more runoff, perhaps chemical runoff from agricultural fields. Increased wetness also increases disease, so the incidence of disease like oak blight. So increasing temperatures and precipitation in the springtime especially makes for a higher likelihood, a higher prevalence of disease. We also get more variability. So I talked about that last summer in Peoria where we got dry, wet, dry. That means that we get drought stress on some of our mesic species like red maple, sugar maple, etc. And it could favor prairie and savanna systems in areas that are on the boundary between prairie and forested ecosystems. Also, the warmer, drier conditions in the summertime that are projected may exceed species ecological tolerance. And these are important tree species we have here in the Midwest. The white oak, which is the state's, the Illinois state tree, black cherry, shagbark hickory. These are really important ecologically and culturally important tree species here in Illinois. With that being said, there are some major adaptive capacity factors that can actually benefit forested ecosystems from climate change. One of those is the fact that we've fragmented our landscapes through agriculture. So what that does is it reduces gene flow, especially from competitors and invasive or pest species of weeds. Tree regeneration in mixed oak hickory forests are low, and they're dominated by drought-sensitive species already. So a lot of our mixed oak hickory forests tend to be less drought sensitive than some of the other more mesic species that I mentioned, the maples. Also, oak woodlands and savannas can better adapt to our projected kind of warmer, drier areas. So there are some adaptive capacity factors in there, but as folks at the Morton Arboretum will say, it's about the right tree in the right place at the right time. So what we're likely to continue to see is that climate change has an overall negative impact on our forested ecosystems, but the right planning, both in urban forested as well as a more naturally forested ecosystems, can make our forest resilient to this climate change. One of the interesting things about climate change as it relates to natural ecosystems, and I get an example here of forested ecosystems, is it's not just, when we think about the role of climate change on forests, a lot of people think about extreme temperatures, extreme rainfall, wildfire, things like that. But climate change has more insidious effects, these sort of combined effects. So yes, we do have, with climate change, increased weather and climate disturbances. So more wildfire, more dry spells, higher precipitation rates, more runoff, higher temperatures, especially in the growing season, those sorts of things. But all of those climate changes not only put stress and disturbances on our native forest species, but they also can make more conducive conditions to invasive species. So at the same time that we have these stressors on our native forest species, we also have the competition from invasive species. And the stress from competition adds to already stress with a climate change on existing species. A good example here, what I'm showing you on the right-hand side, this is from a study back in 2011 that showed tree survival rate in these bars with and without Japanese stiltgrass here in the eastern United States. Now, Japanese stiltgrass is a pretty problematic invasive species. What we see is that the tree survival rate, the light gray bar with Japanese stiltgrass, is significantly lower, particularly in oak and ash species, and to a lesser extent with maple species, than when we have tree survival rate without that Japanese stiltgrass. Now, the sorts of changes in our climate we're talking about for our forested ecosystems here in Illinois does make a more conducive environment for Japanese stiltgrass. So what this means is that the sort of fight against invasive problematic species in our forested ecosystems becomes even more important, considering that can combine the overall stress from climate change. And so what that means is that the activities of folks who work against the spread of those invasive species becomes even more important in the face of climate change. All right, so moving underwater now to some aquatic ecosystems. Air temperatures have increased across Illinois, so have water temperatures. An increased water temperature affects several things as far as aquatic ecosystems are concerned. It affects feeding, it affects growth, and it affects reproduction. Increased water temperatures expand suitability for warm water fishes. That can be beneficial for certain native species of warm water fishes, but it then reduces suitability for cool or cold water fishes, including some of our more important sport fishes across Illinois. Warmer water plus that nutrient runoff, that's sort of the combined warmer and wetter influence from climate change, that nutrient runoff from agricultural fields, it increases the risk of harmful algal bloom in lakes and streams. Of course, the harmful algal bloom also decreases oxygen content in the water, so it's not only dangerous for humans and animals drinking that water or consuming that water, but it's also can be potentially deadly for fish in that water as well. And as we think about more nutrient runoff from extreme precipitation in the spring, but also longer dry spells in the summer, that's when we tend to get those fish kills. And so that is an issue when it comes to aquatic species. Just like we have pressure combining with the pressure and the disturbance from climate change, we also have pressure from invasive species that may be more suitable to a warmer environment. We think about the Asian or big-headed carp and its slow trajectory up the Illinois River toward Lake Michigan. As water temperatures warm both in the lakes and in the streams, it makes a more suitable environment for those invasive species, which again, not only do we get the stress from increased wet and dry spells, increased temperatures, that sort of thing for our native fish species, we also get the increased competition compounding that factor from invasive species. Our avian friends are also impacted by climate change. A study by the Audubon Society in 2019 found that roughly 30% of Illinois' bird species are vulnerable to climate change across seasons. Now, depending on the bird species, we may see changes in winter temperature or rainfall affecting it more than summer temperature or rainfall. But again, there are certain species more at risk than others, and these are, again, important ecologically and culturally important species here in Illinois. There's the bobolink, the red-headed woodpecker, the field sparrow, brown thrasher, wood thrush, just to name a few. Now, just like forest ecosystems, aquatic ecosystems for birds, it's not just a threat from more extreme weather. That is an important part, especially extreme spring heat during reproduction and extreme fire weather that can decrease suitable habitat. We also have at the same time cropland expansion, which decreases that fragments that habitat and makes it less likely that birds can effectively reproduce. And urbanization, again, more of a fragmentation issue. So all of these things added together means that a significant number of Illinois' native bird species are at risk due to climate change. Now, importantly, this is why I cite this Audubon study, because it did a really good job of talking about how mitigation activities can reduce the threat of climate change to bird species, which is really where the rubber meets the road. Not just saying, here's how bad it is, but here's what we can do to fix it. They show that reduced warming from 3 degrees Celsius, overall, that's the global warming, to 1.5 degrees Celsius, would more than halve the overall avian risk to climate change in Illinois. So when we talk about those goals that we need to meet as far as carbon dioxide concentration reduction and overall warming, reducing the overall amount of warming in the 21st century, it's not just doing that to make less climate change. It has tangible impacts on how climate change affects our native natural ecosystems. And in this case, reducing that warming can make a significant difference when it comes to avian species here in Illinois. And lastly, talking about agriculture. Agriculture is an important part of Illinois. We have positive, benefits from climate change to agriculture that we've seen. I mentioned this earlier in the talk. Our frost-free season, the difference between the last spring freeze and the first fall freeze, that's increased by about 10 days statewide. A little bit more in southern Illinois, a little bit less in northern Illinois. And growing degree days are projected to increase by 30% by 2050. So it's not just that we've seen that expansion of the growing season. It's likely that will continue through the rest of this century. However, that's sort of where the benefits of climate change ends for agriculture. Warmer winters, folks may like the idea of, especially in northern Illinois, of a warmer, more mild winter. But just as we talked about vector-borne disease, warmer winters increase the survival and reproduction of insect pests. We saw that this last year with corn rootworm. They're able to overwinter farther north and therefore have a higher prevalence, especially during dry conditions in the summer in northern Illinois. For specialty crops, peaches, apples, blackberries, strawberries, the amount of winter chill hours that we accumulate during the wintertime is very important, and that is projected to decrease significantly. Now, that can be beneficial in some parts of the state, but it can be detrimental to our specialty crops in the southern parts of the state especially. We talk about more intense precipitation. Of course, and we saw that this year when we got lots of extreme rainfall events across central and northern Illinois. We saw crops being flooded out. And it doesn't take very many hours for an active and healthy soybean field to be submerged underwater before those soybeans are no longer productive. So that is a real issue. But along with that, we see more frequent extreme precipitation, increasing soil erosion. As I mentioned, that's an economic impact of farmers just as much as an environmental impact. It also increases nutrient runoff. And there is a real environmental issue when it comes to nutrient runoff from agricultural fields because of extreme rainfall. So it's a bit of a double whammy there. It also, a wetter spring reduces flexibility for treatment and planting. That's really important. We can only do pre or post-emergence herbicide treatment on fields for a short period of time. And if we get a wetter spring, it compacts the overall planting window. Same thing can happen in harvest and reduces flexibility. So you can think about a very wet spring. Not only does that increase the prevalence of pests and fungal disease, but it also means you're not getting your crop in as quickly, or maybe getting your crop out as quickly. So it really creates a lot of stress on farmers overall. And then the projected seasonal variability, in summer where we get more evaporation, maybe more frequent, short, and acute drought. The shorter 1 to 3 month droughts don't really impact water availability in Illinois very much, but they do impact agriculture. So that's a real issue as well. One other thing I wanted to mention, and this kind of spans public health, but also agriculture, because farming is a very, very stressful occupation, is mental health impact. We talked about the physical health a little bit when it comes to exposure to extreme heat, exposure to vector-borne disease. We can think about respiratory ailments as well with air quality. But one of the most understudied aspects of climate change and impacts of climate change is mental health. And honestly, I'll be honest with you, I've been experiencing that the last few weeks, compounded by COVID for sure. But we think about all of these extreme weather events that have been occurring just across the U.S., let alone internationally. We have Hurricane Ida, which flooded out parts of Louisiana and then the Northeast. We had some significant flooding in many residents across north central Illinois in a town called Gibson City that was flooded really significantly. Extreme heat that affects public health. All of these things, they take a toll on us. Whether or not we're directly affected by it, just seeing it in the news can take a mental health toll. But specifically, or especially if you're directly impacted by it, if your home is flooded, if you have somebody with a premature death or respiratory ailment because of these sorts of things, it creates a tremendous mental health toll as well. So that's something, as I mentioned, historically understudied. Having more folks look at the mental health impacts of climate change, but it is significant. And as the effects of climate change are projected to only worsen by the middle to end of this century, it is something that we're all going to be dealing with. So it is a really important aspect of climate change when we consider the overall cost of climate change. The mental health implications are very important. All right, so I've been Gloomy Gus here this whole presentation. And you may be thinking to yourself, boy, this is, well, you may be thinking to yourself, gosh, this guy's off his rocker. But some of you may also be thinking to yourself, this is pretty dire. Is there something I can do? Is there something we can do? The good news is, yes, there is something. There's lots of things. So overall, as I showed, the change in our climate between now and the end of the century and the impacts that we have between now and the end of the century are sensitive to greenhouse gas emissions, carbon dioxide concentrations, methane, and water vapor. So the number one thing mitigation-wise of climate change, decreasing personal and systemic greenhouse gas emissions. With that being said, you may have heard before this idea of a personal carbon footprint. There is only so much living in our current society, in our system, that we can decrease our personal carbon dioxide emissions. So I caution folks when I say decreasing personal greenhouse gas emissions, I caution folks to individualize or personalize their contribution or a contribution to climate change, because we can only decrease that so much living in the environment that we live before our suitability, our livelihoods are really significantly impacted. So there are more systemic things we can do, especially as it relates to mitigation and adaptation to climate change. But one thing I want to make sure of is that folks don't come away feeling an overall sense of guilt, because guilt is a really bad way of motivating action. Instead, people should feel empowered by the change that folks can make through personal decisions, but also through community development. And that's really what I focus on here, is actions through community development. That's really important here. The first one is sustainable urban and rural development. So that means the development of green space. Now, when we look around, just take the city of Chicago, for example, the Chicago metropolitan area, access to green space is highly divergent between neighborhoods. And so as we develop both urban and suburban areas, having access to green space can be extremely beneficial, as well as having accessible transportation so that folks may not have to take their personal transportation. So again, when we think about this carbon footprint, our personal contribution, quote unquote, to climate change, if you think about it, if you were to ditch your car, maybe you don't have the resources to buy an electric car, so you ditch your car. How is your livelihood going to change? Is that even a feasible option? For the vast majority of us, it's just not. But when we think about rural and suburban and urban development, having accessible, sustainable transportation or access to that transportation can be really important for us to live a lower greenhouse gas lifestyle. As well, water management through engineering and design. And so what I'm showing you here on the top right-hand side, that's a parking lot in the Morton Arboretum. And you can see this is a bioswale, green space that not only shades that pavement, but takes in stormwater off of or runoff from the parking lot and filters it through to decrease the amount of emissions, the amount of pollution in that water, and to overall slow down that water movement across that surface and reduce the surge of water when it comes to increased or very intense precipitation. So that's really an adaptive or an adaptation standpoint, is saying we're seeing more intense precipitation events. How can we make it so that we can reduce the impact of those intense precipitation events? And green space and bioswales are great ways of doing that. When it comes to agriculture and food production, sustainability again. So when we think about soil and water conservation, this is an environmental issue, this is an economic issue. When we see years like we did this year, where most of the northern part of the state is in drought, what we see is that those who have employed soil and water conservation strategies and have heavier or more organically rich, overall healthier soils, they do better. And so soil and water conservation techniques are extremely important to adapt to a changing climate, to make for overall more climate resilient agriculture, as well as developing local food supply and demand change. When we think about when it comes to vegetables and fruit production here in the United States, the vast majority of those are produced in areas of the country that have extremely large impacts from climate change, even more than in Illinois. And so developing sustainable food supply chains, both supply and demand chains locally, can be a great way of reducing the carbon, the quote unquote carbon footprint of that food, but also making that food supply more resilient to climate change, which means that we overall have less vulnerability, more food security, and less hunger issues when we are affected by climate change. When it comes to natural resources, habitat restoration is important for many reasons. Of course, habitat restoration along our rivers as well as in our prairie and forested ecosystems, it makes all the world a difference for making a more healthy ecosystem, but it can also help us through water and flood management, the same way that that bioswale and that green space in the top in the Morton Arboretum parking lot does. Having habitat restoration can be really important for water and flood management, which again, adapting to our changing climate. And then when it comes to planning, making sure that not are we only adapting and mitigating climate change, but our emergency management is following suit. So when it comes to how we manage, respond to emergencies and disasters as they come about, it's really important to take into account climate change. So hazard mitigation plans have to include a changing climate and changing risks to these sorts of hazards. The last piece I want to include in there is the idea of a just transition. Now, what I'm talking about when it comes to all of these strategies, these are things that folks can do through community engagement. They can do individually when it comes to the things they plant, the things they grow, the things they do, how they live their lives. But overall, when it comes to vulnerability to climate change, we see that vulnerability born most largely on communities that have fewer resources. And so overall, this idea of a just transition means a transition of our social systems to make us more resilient to climate change, but also reduce the overall magnitude of climate change. So that's what that transition means. The idea of a just transition is to make sure that all people are made less vulnerable to climate change. And so right now, the way that the system typically works is that folks who have the resources to decrease their vulnerability can. Perhaps they can put solar panels up on their roof. Maybe they can spend a little extra money to get locally grown, locally sourced food. Perhaps they can, for example, purchase an electric vehicle where others may not be able to do that, or purchase air conditioning, or afford to use their air conditioning in their home. So making sure that resources are devoted to under or historically underserved communities is really important as we move to a system that's more sustainable, to a system that is overall more climate resilient. So with all of that, I know a lot of information. Again, I really appreciate you, you letting me come and or speak as part of this series on climate change. The last bit of information here at the bottom of this slide is my contact information. Please feel free to reach out to me anytime by email, by phone. Feel free to follow me on Twitter, but also check out the State Climatologist website, which has a lot of really great information. But certainly, if you ever have any questions, issues, if you have things that you're doing that you're excited about that relate to climate change or making your community more resilient to climate change, send me that snapshot. Send me pictures of you doing that, because it's really great to see that as I'm traveling around to the different communities of Illinois to see what people are doing and what people are excited about. So with that, I thank you again, and I hope you all have a great rest of your day.